Our mission is to revolutionize the AEC industry with modern technology that is powerful and scalable, collaborative, and built for non-technical users to ensure that everyone can access and edit BIM models in the cloud. These are the three foundational core concepts that we started with when we designed Qonic from the ground up. The first foundational core concept is performance. To model buildings to the highest level of detail, this would kill any of today's BIM systems. We are developing our technology with real-life and complex models in mind. So how does this work? We use modern gaming and streaming technology to ensure that geometry that is closer to the point of view of the camera is shown in full definition, while model data that is far away is rendered in lower detail. And this makes sure that our technology is scalable. The second foundational core concept is usability. We believe that one of the main barriers for stronger adoption is that BIM tools are too complicated and cumbersome to use, and they require a high level of technological expertise. Nowadays, modern tools should be easy and intuitive enough to ensure that all project architects, field engineers, and people on the field are able to extract maximum benefit from the tools. The third foundational concept is collaboration. We are building cloud-based collaboration software that allows all team members to work together seamlessly, and one of the most significant advantages of Qonic is that it ensures that users can continuously collaborate and make modifications on the same model dedicated to accomplishing a specific cross-functional task. On top of these foundational layers, it is our ambition to create a full-fledged BIM authoring tool, ranging from concept design to detailed design. In terms of geometry editing, we have implemented a full solid modeler with support for most of the common solid modeling tools like push-pulling, sweeping, Boolean operations, and so forth. On top of these tools, we have also added some intelligent BIM procedures to work with the data that can be found in BIM models, such as rules, relationships, and properties. And these are related to the geometric objects in the model. These procedures encode certain understanding and knowledge of basic construction principles in the shape of reusable and automatable procedures. Also, next to geometry, it is possible to work with the data in Qonic. It is possible to edit IFC properties, materials, spatial locations, and also classification systems and measure codes. In Qonic, you can use libraries, which allow you to use and work with data and properties consistently across different models in a project, but also even across different projects. In this way, you can make sure that the BIM data is always structured, consistent, and correct. All of this functionality can be used in a single cloud-based environment. This functionality is also available on all different platforms. It is available directly in the browser, also as a desktop application, both for Windows and Mac, and on a mobile, both for iOS and Android. And all these platforms offer the exact same user experience. We will now demonstrate some specific workflows that are possible with Qonic today. The first workflow is enriching and upscaling existing design intent models. Of course, it is our ambition to create a full BIM modeler, a full authoring tool in the cloud. But of course, this is a huge job. And it is our goal to offer a set of tools ranging from concept design to detailed design, but we have to start somewhere. And in this first phase of Qonic, we have chosen to start at the end and work our way backwards. That means that today we offer the tools to import an existing design intent model with a low level of development, and we offer the tools to enrich it, to upscale it to the level of development of a construction model. A construction model meaning including all full project details and accurate model information. Of course, design intent models often contain missing or incomplete information. For example, low level of development models coming from Rhino or Revit, they don't contain all the information that is needed for construction modeling or tendering in a later phase. The result is that often models get rebuilt. Instead, with Qonic, we want to focus on a workflow where these design intent models can be fixed and enriched so that you can, for example, add BIM information to design models coming from Rhino, or that you can fix and enrich IFC models or further detail Revit models.
Yes, Steven, thanks for this introduction. Let me show some of these data editing tools in Qonic. So I have here a bunch of IFC files. Let me upload an IFC file into this project here. It's an MEP file. So all of these models here in this dashboard that you see are separate IFC files, are all stored together in this single dashboard. So if I want to, I can open all of these models, these different disciplines, together in one session. Actually, let me do that. So let me open all of these 7 models. I can choose to open this in the browser either or in the desktop application. Effectively, there's no difference between these two environments. The only difference is that the desktop application can, of course, use the full capabilities of your desktop. So for heavy models, it's recommended to use the desktop application. So let me just continue in the browser for this relatively small model here. And you'll see that at first glance, this model looks pretty good. But when looking a bit closer at the data in this model, I will notice that it contains a lot of inconsistencies. So for instance here, these solar panels are classified as building element proxies, which is kind of a generic IFC class. Actually, let me select all of the solar panels. I'm just using the search bar here and using a keyword solar to find all of the solar panels. And let me check the properties, and I will see indeed that all of these entities are classified as building element proxies. So using Qonic, I can rectify this. I can assign a new IFC class to these objects. So I'll reclassify them as the proper type, which in this case would be solar device, more specifically solar panel. So let me apply this change here. And if I now again select all of these solar panels, I will see all of them are correctly classified as solar devices. I can also see a whole bunch of properties, attributes, relations. These follow the IFC schema, the IFC structure. And I can start to modify this information. I can either change property values, or I can add properties or remove existing properties. So for instance, let me add some properties from the IFC schema. Let me check for solar device type common properties. So this is a predefined property set by IFC. And I will add all of these 4 references, these 4 properties to these objects. I can already give some values. And save these values to these solar panels. So now these properties are added to these solar devices. I can not only use predefined, pre-existing data sets or property sets, I can also use or create my custom property libraries. So for instance, when adding properties here, I can choose here for my custom property library. For these selected entities, I have one property set that's applicable, which is these solar panel properties. Managing these properties is done in a separate library. So actually, let me open this library here. I can see I have these same properties available here for these solar panels. So I can add any kind of property definitions. I can choose a data type, measurement type, and so on. So all of this can be managed. And the reason why we do this in a library is so that you can have consistent data across your models and even across projects. So when applying this to the model, I can again choose these pre-existing or choose these defined properties, give them some values, and I can save this. So basically I've used Qonic as a IFC data editing tool in this little demonstration. I'll give the word back to Timon and he'll introduce the next workflow.
The next workflow that we would like to demonstrate is the 3D modeling. So how can we create 3D models with a higher level of development? Of course, as said before, it is our goal to create a full BIM solid modeler. For solid modeling, there are two main approaches. On the one hand, you have direct modeling approaches with push-pull operations so that you can create any shape in a flexible way. On the other hand, there are very specialized intelligent BIM procedures which can be used to automate the modeling of real-life construction and building systems. Think of tools to create assemblies, building products, details, connections, and so on. And we believe that it's possible to offer a modeling approach that combines the best of both worlds. So with Qonic, we offer a unified environment where you can nimbly navigate between these two modeling approaches. So on the one hand, generic push-pull modeling. On the other hand, using the BIM data that is in the model to create smart and automated procedures.
Okay, let me demonstrate some of these modeling and geometry editing tools in Qonic. So I've opened a model here. Again, it's an IFC file that was uploaded to Qonic. And we can now simply start to modify this geometry in this IFC file or in this model. For instance, I can start to modify the floor layout. Let's say I want to move this wall here. As you can see, we have these interactive dimensions that we can use to accurately place our geometry. So for instance, I want to move this wall so it fits, so these cabinets fit snugly between these walls. And as you can see, when moving the wall, of course, the doors within the wall were moved with it. The other wall here was also adjusted in length. So that's actually thanks to our intelligent modeling kernel underneath the hood of Qonic. Let me modify this wall here, let me push-pull it, so it's aligned with the outer wall here. And I'm using actually 3D snapping for this. Anyone who has been using 3D modeling and has done snapping in 3D modeling knows that snapping in 3D is sometimes tricky. Sometimes you don't find the snap point that you're looking for, or you accidentally snap to something that's behind something else. That's why we've basically created a sort of dynamic, intuitive snapping system based on the context. So for instance, if I want to push-pull this wall here, I get a bunch of snap targets, and I can easily align it with, for instance, the outside of this wall. All right, let me take a look at the materials in this model. So for instance, this wall here, if I check its properties, I can see it has a set of materials, but they're not visible in the model yet. That's because in the IFC file, these materials were not specifically, or were not specified as individual solids or objects. It was basically one part with a material layer set. We can use Qonic to split these walls in their parts so that we can individually modify them. So to do that, let me just set this building in scope. And also I'm going to temporarily hide all of the furnishing elements and flow terminals so I can see a bit better what I'm doing. All right. And now let me just select everything and choose to split into layers. So I'm basically splitting all walls and slabs that have a material layer set defined in the IFC model into individual layers. I can still interact with this little preview. Sometimes the layer order of some walls is incorrect, so we can still flip these around where necessary. And now I'm splitting this. And once split, the result is actually each wall will become an assembly with individual parts that can be individually modified, both in geometry and data. So for instance, now I can choose to use these individual parts to correctly define connections, things like that. So in this case, I'm individually connecting wall by wall. But in a future version, of course, of Qonic, we will be able to automate this, so you don't have to manually rectify these connections. You can also choose to go in and select individual wall layers. For instance, this middle wall layer I want to connect. Oh, actually, I want to connect with this layer here. So you have really granular control over the individual layers and materials in your model. I can also see here, for instance, that this outer layer here of this wall, if I check the properties, I can see it's actually insulation material, which makes no sense because this is a division wall between two balconies. So let me just get rid of this one layer, and I'll just copy this brick facade to the other side as well. So even within an existing layer structure or wall assembly, I can still modify materials, layer orders, and so on. I can also individually modify this by, for instance, by push-pulling. So let's say I want to set these back a little bit and add another layer, like a wall cap on the end here. That's also possible. I can also use this add layer functionality to, for instance, add some finishing layers. So let me choose some gypsum. And I'll just add some finishing layers to this, let's say this living room here. I can just click individual walls to show where I want to apply these layers, these finishes. Of course, also in a future version, it will be possible to assign finishing layers to entire rooms at once, or to types of rooms, for instance. But this flexible approach allows you to also model, for instance, the inside finishes of window openings. So you have a really flexible way of modeling these details, which in a later stage will become important if you want to, for instance, get a quantity takeoff of your model. All of these extra finishes that you add in the inside of the windows will make a big difference in the final quantity takeoff. Alright, so let me add some more finishes to, let's say, this little room here. And I'll use some tiles. Again, I'll just click one by one the wall that I want to apply the finishing to. And here you can see, actually, for this particular wall, I have two different finishes along the length of the wall. So it's possible to have different combinations of finishes and wall material structures along the length of a wall. It's a really flexible way of modeling, actually. And again, all of our tools are context sensitive. For instance, if I would move this wall here, you'll see that all of the connections are retained. So the connection between different walls and materials are retained. But we don't actually store these constraints or these connections in a sort of constraint set. This is all calculated on the fly to keep our models light and to not over-constrain anything. All right, that's a little example of some of these modeling tools in Qonic. Timon?
So far we have seen that you can model with the highest level of development, and that it's also possible to fix or add missing BIM data. For example, missing properties, class information, material information, and so on. This is our goal. We want to enable users to create models with a high level of development that can be used for full project detailing in the end. This will enable, in the end, more accurate quantity takeoffs during a tendering phase. For example, this tendering can also be done on details such as parts, finishes, and so forth. This is what we will show in the next demonstration, how we can use the quantity takeoff tools on a highly detailed BIM model.
Okay, so I've opened the same model as before, only now I've already added some finishes to all of the rooms here. Let's take a look at some of the quantities in this model. So for instance, this wall here consists of different materials, different layers. And if I would calculate the net area of this wall, I would get a value of 4.5 square meters, which is basically along the center of the wall thickness. It has this net area. But of course, this net area differs for different layers in my wall. So for instance, if I would calculate the net area of this inner structural layer, I get 3.7 square meters. Whereas for the outer finishing layer here, I get an area of 5 square meters. It's quite a big difference for just this one single simple wall. And it's this difference that will make the difference for instance, for contractors who want to do a quantity takeoff or an estimation during tendering phase. Now, of course, we don't want to manually measure all of these quantities ourselves. So we can automate this using existing systems, classification systems. So let me show you what I mean by that. So we have these codification libraries in this project. In this case, there's already one codification system present, which is the NRM system. I can add any other system from this library of systems. For example, Uniclass, NRM. All these commonly used systems are available through the Building Smart Data Dictionary API that we're connected with. And all of these systems, or some of these systems, actually come with measurement definitions for certain codes. So for example, in NRM, internal finishes for walls should be measured according to these measurement definitions. So for finishes to walls and columns, the area should be calculated and so on. These measurement definitions are defined within the system that we use and can be used to automatically calculate quantities in the models. So for example, let me go back to the model here, and I already applied some of these classification codes from NRM in this model. Let me search for the external walls, and I can see I have two different codes for external walls. On the one hand, actually let me set it in scope. On the one hand, there's this code 2.5.1.1, which applies to the entire external wall as a whole. And on the other hand, there's also a separate code only for the finishes, which is basically a subset of this wall. And if you calculate these areas, you will see this in the schedule, and there's quite a big difference between those two values. So let me show that actually in the schedule. So this schedule is generated based on the model and based on the codes that we applied in this model. In this case, the NRM codes. And if I would search for the external walls here, I can see again these same two codes that I've showed you in the model are visible here in the schedule as well. And we can see that the external walls as a whole have a net area of 2,400 square meters, whereas the finishes of these external walls have a net area of 2,540. It's more than 140 square meters difference between those two codes, even though they apply to the same objects. Applying these codes in a model is actually quite easy. Let me just reset my scope. Let's say we want to apply a code for the internal finishes, for the plaster finishes, for instance. I can just search for the plaster, select everything, and I will codify them with the correct code, which in this case would be this one here, wall finishes, which in this case will be measured in net area. Okay, so once applied, if we now update the schedule, this code will now also appear in the schedule. So you can easily get your quantities out of this automatically.
The next workflow that we would like to demonstrate is how to collaborate with multiple people on BIM models. Of course, a design process is highly iterative, and that's why we've built in a versioning system that is very similar to Git, which can be used to collaborate on projects with multiple people together. The basic idea is that there is one central public model that is available for everyone, and everybody can make changes in their own personal version of that public model. These changes can then be published or synced so that they become available for everybody else, for every other stakeholder that is involved in the project. This way of working together asynchronously has several benefits. First of all, it allows you to track the entire version history of your model and the changes. So it allows you to look back in the history and even revert to previous versions of your model. Secondly, it allows you to work in a structured way with conflicts. So for every change, you can choose which version you want to keep and how you want to deal with changes and access rights. Thirdly, this workflow also allows you to work in an offline way. So it's possible to download your models up front, make some changes, for example, on the site, and then sync your changes when you are back online.
Okay, so I have a project open of a office building consisting of 7 different models. Let me open all of these models here. I will use the desktop application for it this time. And I'll make some changes in these models. All right, so let me activate a section. And I'll make some changes to the floor layout of this part of the building. For instance, let me get rid of these 2 walls here. And let me connect some other entities. I'll also copy this door because I've basically made a new room here. And I'll make this room a bit bigger by moving these 2 walls. Like this, okay. So I've made some changes to these models. All of these changes are automatically saved to the cloud because Qonic is a cloud application. So you can see here that the last save of this model was done 12 seconds ago. When I'm happy with my changes, I can choose to review these and to publish them. Because basically my changes are not yet available for other people in the project until I choose to publish these changes. So I can access the entire version history of a model. For this particular model here, I can see it was first uploaded about a month ago. Changes have been made over time by different people, so we can have different or several collaborators, multiple collaborators on the same model, making changes through the history of this model. So the entire history is available. You can always revert back to an older version. And at the top of this version history here, you will see my personal changes. Basically, the changes I've made in the past few minutes here are not yet available for other people to see because I still have to publish them. So let me just publish them. I'll add a little commit message. Something like this. I can choose to add a description, or I can get rid of the auto-generate description and just publish this. So now these changes are available for other people who have access to the same model. Now, of course, I can already hear you think, okay, what happens if multiple people make changes to the same model at the same time and those changes conflict? We do have a answer to that, so let me actually simulate a two-person workflow. On the left-hand side, I'm logged in as myself here. On the right-hand side, I am logged in as my fictitious coworker, and we will now make changes to the same model at the same time. For instance, this structural model here, let me just open it in both separate browsers. And we'll make some changes that conflict. So for example, this model contains some foundation slab or some floor slab. And maybe person A thinks, okay, this floor slab should actually be extended along the entire length of the building. So let me rectify this and let me push-pull this floor slab to the end of the building. So it basically covers the entire building, like this. Again, I'm using snapping in 3D, so I can really easily align it with existing geometry. Let's do the same on this side. Okay, so person A has extended this floor slab so it covers the entire length of the building. Maybe the other person thinks, okay, this floor slab is clearly incorrect, let's just get rid of it and ask the engineer to remodel this properly this time. So both changes are obviously conflicting. So what happens if we now want to review and publish these changes? So let's do that to check it out. Again, the version history that you can see on both sides of the screen are the exact same for both persons. The only difference here is the final commit here, which isn't committed yet. So the final publish, the personal changes are different for this person and for the other person. So let's say I publish this, and as soon as this is published, Qonic will in the background try to combine the changes of this left-hand person session to the other person's session. So if these changes can be merged or combined together with no problem, then as a user you won't notice anything. It will just go automatically. However, if there are merge conflicts, as we call them, you will be notified by the system. So in this case, Qonic couldn't merge the changes, so it needs to be resolved manually by one of the two persons. So for instance, now Lewis can choose to either prioritize his own changes or the changes in the public version, which were made by the other person here. In any case, you can always go back to a previous version, so you can always revert or roll back to an older version of the model.
The workflow that we have shown so far is of course just the start. You can easily envision a more extended version-based workflow where you can work with different branches and different options all together. We're also at this moment working on a visual system where you can decide on an element level which version you want to keep working with. So we don't work with entire files, we only work with the small changes, the small diffs, which is a much more lightweight and granular way of working together. Of course, next to working together on the same model, interoperability is also important between different authoring tools. So we want to work together, we want to be highly compatible with other authoring tools, and the primary way of sending data between Qonic and other applications is through IFC. IFC is the primary interoperability way of Qonic, but next to IFC we also offer some other options. For example, we offer a direct Revit link. At this moment we support import of Revit models into Qonic, but we're also working on exporting models from Qonic to Revit. Also for Rhino, we have a direct import so that you can also directly import Rhino files into the Qonic environment.
Collaboration is not only about working together with other people in the same software. It's also about working together with different models of different origins and different software. So I'm going to show this using an example of this famous project by Zaha Hadid, which we actually have 3 separate models of. We have, let me check, we have the Revit file of the internal architectural structure of the building. We have a Rhino file which where the flowing roof is modeled, and then there's an IFC file that contains the site context for this building. All of these file formats, so Rhino, Revit and IFC, can be read in Qonic. So when adding a new model, I can choose to upload either an IFC file or a 3DM file, or I can choose to bring a Revit project into Qonic using the Qonic plugin for Revit. So actually I have Revit open here with this project, so the internal architecture and the glass facades of this building in the Revit model, and I will bring this over to Qonic using our plugin. So I'm logged in with my account in Qonic, and I can see all of the projects I have access to. So I'll choose the particular project I want to add this model to. And now it's going to convert this geometry and data to the Qonic database. Okay, so while this is happening, let me go back to the dashboard. And let me also upload a Rhino file. So the Rhino file of the roof. Okay, so this is going to process now for a few seconds. In the meantime, let me show you what the model actually looks like in Rhino. So I have a Rhino session open here containing this model of the roof. So as you can see, it's a fairly complex geometry with complex curves. All of this geometry is supported in Qonic and will be able to be edited. Okay, let me go back to the dashboard here. And in the meantime, I will upload the final file of this project, which is an IFC file of the context model. So again, I'll just drag and drop it into the dashboard. I can choose access rights, and it's going to process now. Let me check in the meantime how the Revit conversion is going. Okay, so it's converting. Depending on your internet connection, of course, this can go faster or slower. Right. Okay, so the architectural model from Revit has now also appeared in the dashboard. It's still processing. Let's just give it a minute. All right, so the roof in the meantime has also finished processing. Now it's only the Revit model that still needs to come through. Okay, there we go. So let me open all 3 models. To get a combined view of all 3 disciplines. So as we can see, we have the roof coming from Rhino, the architectural model of the interior here, and then the site context, which came in through IFC. And now we can start to modify these models, so it doesn't matter whether it came from Revit, from IFC, from Rhino, we can modify them all the same.
The next workflow that we would like to focus on is how to make BIM accessible across all stakeholders that are involved in a project. This is about sharing designs and models. And Qonic, next to the authoring functionality, also has its own collaboration platform. So in this collaboration platform, it is possible to set up your organizations, your projects, and your models. There is a permissioning system built in, which allows you to provide users with the correct access rights so that you can effectively and safely work together. For example, it is possible to give people access rights such as viewing, editing, or admin rights.
You can see this project has a number of collaborators here on the right-hand side. However, not all of these collaborators are part of the same organization. You can see this a bit more clearly when I go to the project settings, that there's, on the one hand, there's members of my organization, Qonic Design. So these are my co-workers who have access to this particular project. But I also have external collaborators, external members. For example, they could be subcontractors or some third-party stakeholders. In this case, I can see Team in here is an external collaborator. Adding new collaborators is easy, just send them an email invite. For instance, I can invite Mark here as a user for this project. Now, Mark will by default not have modeling or editing access in any of these models. So per model, you can define access rights. For instance, for this particular model, I can see Mark only has viewing rights for this model. I can change this for him being an editor, for instance. So all of this can be managed by the model owner or project admin. Sometimes you don't want to necessarily have someone create an account for Qonic. If you just want to quickly share a model with them, it's also possible. So there is a public sharing option available so that anyone can open this model. You don't even need a Qonic account. You can just click the link, it will open the viewer, and they will be able to view the model. So for instance, for this particular model, let me just maybe change the validity date here and copy this link. And now I can just, in a new tab, for instance, paste this, and I will be able to view this model now. Of course, it's read-only because I'm not logged in this particular session, so I can only view the model. I can read some properties, I can do some measurements, and so on. Sometimes you even want to go a step further and only share a particular part or subset of the model. For instance, if I would search for all steel objects in this model here, it is possible to combine this search query in a shareable link. Okay, so I have the selection of all steel objects in this model. Now I can copy this link, and anyone who has access to this model and who opens this link will see this particular view of the model with only the steel structure selected. As mentioned before, Qonic is not only available on browser or desktop version, it is also available on Mac and iOS, as well as Android. So let me actually switch my screen here to this tablet I have next to me. So I have the same model open in a tablet. And I can do the same things as I can do in the desktop application. So I can navigate around, I can find some properties of some objects, for instance. The entire user interface is the exact same across all platforms, including mobile phone or tablet.
As we said before, Qonic is available on all devices, such as desktop, directly in the browser, and mobile versions, so that Qonic is really accessible. So everybody can easily access the BIM data that is available on Qonic. The desktop version is the most powerful platform, which can be used in the office for BIM modeling. The browser version is very accessible because you can just open a model through a link without needing to install local software. So it's very convenient to use. And the mobile version is very accessible, for example, also on the site. So all these platforms provide exactly the same user interface and user experience. For us, this multi-platform approach is key for making Qonic work and for making the BIM data really accessible, because this allows people to accelerate the collaboration and the adoption of BIM across all different platforms and disciplines. And this is, of course, what Qonic is all about. We are now at the end of our product demonstration. We have shown a lot of cool new features, and we hope it gave you an idea of what is already possible with Qonic today. Of course, this is only the start of Qonic, and we will now show you also a glimpse of the future roadmap and the functionalities that you can expect in the coming months.
Hi, in this demo I would like to discuss a bit the modeling philosophy in Qonic. And along the way I'll also show you some sneak previews of what's coming next in terms of modeling for Qonic. So, first of all, we want our modeling to be three things. We want it to be flexible, efficient, and also intuitive. To meet that first requirement of flexibility, we've decided to include a complete direct modeling toolset into Qonic. Direct modeling, that's push pulling, slice, booleans, etc. So with that, you'll be able to just go in and grab any object in your model and start, for instance, push pulling on it. And here I'm modifying the Qonic logo a bit, and that demonstrates that this works on any type of geometry. These are the side faces of the logo are NURB surfaces, for instance. But secondly, it also should work on any object in the model. A window like this, for instance, in your typical BIM tool, it will probably be some type of parametric component, which you can only modify by either accessing its parameters or by going into some block or family editing mode and modifying it that way. But in Qonic, you'll also be able to just grab the faces of this window and modify them directly. A bit more about windows later, but in general we think that this base layer of flexible modeling tools is very important, not only during early conceptual design where you want complete modeling freedom, but also during later detailing phases, because there will always be limits to parametrics, to procedural methods, and there will always be situations in which you want to go in and fix things manually. But of course, modeling a whole project like this using only these low-level modeling tools would not be very efficient. And that's why we also need a second category of modeling tools more dedicated to BIM modeling workflows. And to talk about that a bit more in detail, let me first literally limit the scope of my presentation to one of the floors of one of these buildings, and let me also just remove the furniture from view to make it to have a good overview here. Next thing I'm going to do is to split the walls and the slab in this model into their material layers such that I can edit them later, as Jacob also showed already. Now, one of the things I can do now is to start connecting these walls. This connect tool, by the way, is a first example of what you could call an object-based tool, because it knows the concepts of walls, slabs, materials, and based on this knowledge it's able to figure out which geometric connections to make. It's also very intuitive. I just have to click on the entities I wish to connect, and there's not much settings involved, as you can see here. And the reason we're able to do that is because there's always the fallback of direct modeling when things would go wrong. And in fact, a tool like this is actually just a layer of automation on top of direct modeling machinery, because I could just have created this connection using a series of push-pull, as I'm doing now here. And the result is actually completely equivalent. For instance, if I move this wall, both connections are restored correctly, both the manually created one and the automatically created one. And that is actually very important in our modeling strategy. So we don't store any connection information in the model. We keep the model very lightweight, and also that means that tools like the Move tool do not depend on the modeling history of the geometry. That means they can work on imported models as well as models created in Qonic. And actually this is the key ingredient why we can integrate direct modeling with these smarter BIM tools. We keep the objects dumb and we make our tools smarter. You will hear that again a few times in my presentation here. And a second, more dedicated BIM tool has also been shown already by Jacob, and that's the Add Layer tool. This is a tool which allows me to easily add finishing layers, for instance, to a wall just by clicking on the location where I want to add that layer. And so again, this is very intuitive. It's much like using the paint bucket in good old Paint. And it's also flexible because I can just as easily add, for instance, this finish inside these window openings without having to go into wall settings, etc. It's also working well together with our direct modeling tools. For instance, if I select the layer here I just created, then I can just slice it at a certain height above the floor. Then I can just delete the lower half of this and replace it with a layer of a different material, for instance, some tiles. And now I have created a wall here with two different types of finish on top of each other on the same side of the wall, and that was really intuitive and easy. So we have intuitive, check. We have flexible, check. But in terms of efficiency, still improvement can be made. For instance, even if this adding of layers by clicking is very easy, it would still be a lot of work to do this for the whole model. So we're thinking about creating layers of automation on top of this. And I can already show you a prototype we have here. It's hidden a bit inside the developer section of Qonic. And this prototype, it will allow me to not only add layers to individual wall surfaces, etc., but it will allow me to just click anywhere in a room and automatically have the layers added around the perimeter of the room in one click. For instance, it also added these layers inside the window openings here automatically. And now I can easily repeat this in other rooms. I can click around in the model and have all rooms finished in one go very easily. So this is already productivity gain on top of the initial add layer. Also note that I have said that the tool detects the room boundaries. That's literally the case because in this model here, which we have imported through IFC, there's no IFC spaces. And in order for our tools to be able to work regardless of the history of the model, we made the tool smart enough to automatically, in this case, detect the boundaries of the room on the fly using analysis of the surroundings of where I clicked. So this is again an example of keeping the model or the objects dumb and the tools make the tools smarter. Along the same lines, we're thinking about certain types of detailing which are typically cumbersome, like a form of sweep details. For instance, if we want to add a baseboard like this around this room, we would typically have to go into wall settings to define these baseboards for different wall types that's around the room, or we would have to manually follow some sweeping path to create the sweep. So we're thinking about how to make that easier, because if it's too cumbersome, it doesn't happen. You don't have the correct quantities in your quantity takeoff. And so here we have a second prototype that wants me to select a profile for the baseboard. I have to select a material, and now I can just click somewhere in this room, for instance, and the tool will automatically again detect the boundary of the room and add a suggest baseboard there. Now we see that this baseboard doesn't have the orientation we want yet, but instead of having to go and manually position the profile, I can just browse through the suggestions made by the tool and select an appropriate one. So now I have this baseboard which nicely makes the return in the window opening. It nicely stops at the door frames, is nicely mitered in and around all corners. And this was very easy to do. And I can just as easily repeat it in the next room to have a baseboard added there as well in one click here. So this makes it really easy to add details like baseboards, and also it has some extra possibilities. For instance, you may have noticed that I added the baseboard before adding the plaster finish in this room. That I did on purpose, because right now if I go to the layer adding tool again and add the plaster layer after I added the baseboard, you'll see that the layers now nicely stop on top of the baseboard, and this way I've created this nice recessed baseboard here with a shadow line on top of it. And this was all very intuitive. If I had added the plaster layer first, then the baseboard would have been placed against the plaster layer. So by mimicking this construction process a bit, we make the tool also more intuitive for non-technical users. So this is a bit how we're thinking about detailing, and another good example of how we think about modeling and detailing is things like windows and doors. For instance, here we have a window on top of which we have added two lintels, one here on the inside to support the supporting layer of the wall, and one here on the outside, steel bracket, to support the facade bricks. But as you can see, these are not included in the window definition itself. That is also how it should be according to us, because for one thing, they're probably not produced by the same manufacturer, and also not installed by the same contractor or subcontractor. So you want to keep them separate for quantity takeoffs on the one hand and planning on the other hand. However, you would be tempted to put them inside a window definition or window family, because you want some associativity between the window and these details. For instance, if you move the window, you want them to move along. If you would resize the window, you probably want to resize them as well. However, putting them inside a window definition has some serious drawbacks, because, for instance, there's an enormous explosion of possible combinations. You have different types of windows, different sizes, different types of lintels. Then you still have to add window sills, the interior window, side finishes, etc. And having to create and maintain all these definitions would just be non-practical. Instead, in Qonic, we follow a different approach. If we move this window, we again on the fly detect the associated details surrounding it, and we automatically move them along. And to show you really what this means, let's copy this lintel here to this other window and adjust it to fit this other window. I will do this completely manually by using some direct modeling tools. Here I'm creating a correct overhang, and then let's make the lintel a bit longer with the push-pull, and let's create it oversized for now, because now I can go in, use the slice tool relative to this side face of the window, and I can cut it to the exact length I want, and then I can delete the excess here. Now I still have to move it upwards to the correct position, which is very easy with our dynamic snapping. And finally, I still have to do something because the wall and the lintel are clashing right now, so I can use the subtract tool to subtract the lintel from the wall like this. And this is really all I had to do to put the lintel there, because now if I move the window, you'll see that automatically this lintel is picked up when moving the window. Also, when copying this window to another wall like this, like that, you can see that the lintel is also copied with the wall, and its length, its cavity, I mean, is also created into the wall automatically, as you can see. And we're developing further in this direction. We already have some prototypes for helping to automate this process. Unfortunately, I cannot show them yet in Qonic. The UI UX is not ready for that. But since we really wanted to show this, we've decided to show it in our internal test application, which is called Qonic. And it's really a playground for our developers to create prototypes in. So please don't look too much at the UI of this tool. It's on another level. But that shouldn't keep us from demonstrating some cool things. For instance, I here have a tool called Copy Window Detailing. And what that allows me to do is to select an example window, click on a target window, and automatically the detailing is transferred to that new window. For instance, the lintel on the inside, but also here the L bracket on the outside has come along. And not only have they been copied, they've automatically been resized, keeping the correct overhang on either side of the window. I can easily repeat that process to bring the detailing to even other types of windows very easily. So the next step, we can automate that, let Qonic suggest automatically to bring details to several windows in your model at once. And note that these lintels were really dumb objects. We just modified their sizes on the fly. And actually we can use that same technology to modify the size of this window, which is also a dumb object, because whatever parameterization it may have had in the original BIM tool has been lost through the process of export to IFC and import in Qonic. But we created this window size tool that just allows you to grab such a dumb window and change its size automatically like that. There's even some options to keep the divisions proportional or not, and this is all detected on the fly. And what's even better is that not only the window is resized, again, these details we've copied are automatically adjusted as well, based on the window resizes. So that is a good illustration of our point that we want to be able to combine two modeling paradigms. We want complete, flexible, freeform direct modeling combined with smarter BIM tools that are really smart, allowing us to keep the objects dumb, and this allows the seamless combination of these two ways of modeling. Okay, so this is what I wanted to show today. Thank you.